In this video I would like to introduce you a very nice problem of Polish Mathematical Olympiad edition 2005. Here is the following information. Determine all n as a natural number such that we have 2 to the n plus 105 is a perfect square. Okay, so there is a bunch of ways to solve this one. You may go through the factorization and transfer this one into the product. You can also use the congruence definition. Okay, so I will be recommended to give the try to this problem before getting to the solution. Let's go ahead, pause this video. When you are come back to see the full solution. Now let's jump into the solution. So we are saying this a perfect square must be written on the following way: equals x squared. Okay, now I'm going to reduce this one to mod 3 to check where we have the perfect square. Let's take the list. Let's take, for example, 0 square is 0 square mod 3. I'm going to reduce this one to the mod 3. So for 1 square is giving us 1 mod 3. Okay, so 2 square, which is 4, is giving us 1 mod 3, because 4 is 1 more than 3. Okay, for 3 square is a congruent to 0 mod 3. So for the next term, 4 square is a congruent to 1 mod 3, because 4 square is 16. 16 is 1 more than 15. Okay, so for the next term, 5 square is a congruent is 25. 25 is 1 more than 24, which is congruent to 1 mod 3. So for the 6 square is a congruent to 0 mod 3, because 3 divides 36. Now if we take a look at all terms where we have perfect square, so we have perfect square. This one you keep repeating 0 1 1 0 1 1 1 0. That means we have a perfect square at 0. So that means 0 and 1 are only perfect square mod 3. Okay, so we have 0 and 1 are only perfect square mod 3. Okay, now we know where is the perfect square. Perfect square is 0 and 1. Okay, so now I'm going to break this one into cases. If n is odd, I'm going to reduce this one to mod 3. So we have x squared equals 2 to the n plus 105. So x squared equals 2 to the n plus 105 equals 2 to the n. We know 105 is the same as 3 is multiplied by 25. Okay, by reducing this one to mod 3, so you get 0 here. This one goes to the 0 because 3 divides this term. This one goes to 0. I will have here minus 1 to the n is a congruent. N is a odd. This means this one is turned to minus 1. So it's congruent to minus 1 mod 3. Okay, so that means x squared is a congruent to minus 1 mod 3. But this is not perfect square, because the perfect square it was 0 and 1 only. Okay, so that means no solutions. That means we have no solutions for above equation when we have n is a odd. Now let's move on to the next case. When we have n is a even. N is a even. Let's set n equals to m. Okay, so I will have to the 2m plus 105 equals x squared. Then I'm going to move over this term to the right. I will get x squared minus 2 to the 2m. I will get the quantity square here, m squared equals 105. If you take a look here, I have the difference of two squares here. I'm going to factor out this one. We'll have x minus 2m factor x plus 2 to the m 105. I can write 105 in many different ways, equals 105. Okay, so I will have x minus 2 to the minus 2 to the m factor x plus 2 to the m equals 105 is multiplied by number 1 is the same as 3 is multiplied by 5 is multiplied by 7. Okay, like this. So I will have too many cases here. Let's put the first case. Since this term is bigger than this term, first thing we are going to check the parity of this one. If you take a look at the right hand side of this equation, this is x is a odd. X is a odd because the left hand side of this equation is odd, because here this one is a even plus odd is given as odd. Since x is a odd, so that means this term odd minus even is given as odd. That means this is odd. This means both terms are odd. And also, since we have x as a positive integer, that means this term is bigger than this term. In the other word, this term is taking the bigger term. This term is taking the smaller term. Now we will have too many cases here. Let's start with the first equation system. So the first term as a big number, x plus 2 to the m, is taking the whole thing, 105. Then the small term, x minus 2 to the m, is taking the minimum value. So we're doing this one because we know this number is odd. We know both terms are odd. Okay. The next equation, I will have x plus 2 to the m equals, is taking 3 is multiplied by 5, which is 15. Then the small one is taking number 7. Okay. The last equation, x plus 2 to the m, is taking 21. 3 is multiplied by 7, which is 21. So the last term, the small one, is taking x minus 2 to the m, is taking number 5. Okay. Now I'm going simply to solve this equation. So this is first equation, this is second equation, this is third equation, this is fourth equation. Okay, system. So I'm going to check with this one by adding first equation and second equation. These 2 to the m will be cancelled out because one is positive, the other one is negative. I will be left with 2x here. 2x equals 105 plus 106. So that's mean 2x equals 106. In the other word, x equals 53. By plugging this found fact into the second equation, I will get here 53. By taking this minus 1 to the left, I will get 52. I will get 53 minus 1, which is 52. By taking this 2 to m to the right, I will get 52 equals 2 to the m. So 52 is not a power of 2. That means it's not a solution. Okay, you can put no. Okay, let's move on to the second equation. So by doing the same job, adding first equation and second equation, you get here 2m will be eliminated. I will get 2x equals 3 plus 35, which is 38. So we'll have 2x equals 38. In the other word, x equals 19. Okay, by plugging x into the second equation, I will get 19 minus 3, which is 16. I will get 2 to the m equals 16 is the same as 2 to the 4. Now I found the solution m equals 4. Okay, I'm going to put the solutions at this empty space. I'm going to put the solutions in this empty space. So as I found m equals 4, so I will already have n equals to m. That's mean n equals 8. Okay, this is the first solution. Okay, let's check the second solution. So let's move on to the third equation. By adding the first equation on the second equation, I get 2 to the m is eliminated. I will get 2x equals 7 plus 15, which is 22. By dividing both sides by 2, I will get x equals 11. X equals 11. X equals 11. By putting 11 into the second equation, I will get 11 with this minus 7, it becomes 4. I will have 4 equals 2 to the m. So we'll have 4, which is 2 to the 2, equals 2 to the m. Okay? In the other word, m equals 2. So since we have n equals 2m, I will get n equals 4. So n equals 4 is the second solution. Okay, let's move on to the fourth and last equation. So by adding the first equation and second equation, I will get 2 to m eliminated. I will get here x plus x, which is 2x. I get 21 plus 5, which is 26. So we'll have 2x equals 26 I get x equals 13. X equals 13. By putting the value of x into the second equation, I get 13 with this minus 5. 13 minus 5 is giving us 8. We'll get 2 to the m equals, which is 13, minus 5, which is 8. Heat is the same as 2 to the 3. Okay? So now I found the value of m equals 3. Since I have n equals to m, that means n equals 6. N equals 6 is the other solution. Okay? Now I have done with this problem. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.